Have you ever wondered how a magnet works? We know magnets can attract and repel, but how? What defines a magnet? Magnets are made from ferromagnetic materials, and ferromagnetic materials have some unpaired electrons in the atom, which creates a magnetic effect. There are two types of magnets: permanent magnets and electromagnets. A permanent magnet's magnetism is always on, while electromagnets are in the middle with any electric current flowing through it to make it create a magnetic effect. Which leads to the fact electricity and magnetism are very closely related. Electricity and magnetism are two sides of the same coin, much like mass and energy and time and space. They both produce forces and create fields. That's why particles with electric charge are often called intrinsic magnets. Both electricity and magnetism are part of the same fundamental force, the electromagnetic force. They both store the power of electrons. The rotations of electrons create both magnetic fields and electric fields. Now, inside an atom, we have neutrons with no charge whatsoever, and protons with a light charge, all clumped up in the middle. And then we have electrons, which have about 1,000 times stronger force than protons. So the magnetic energy focuses on protons. The electrons rotate around the nucleus, and they themselves rotate as intrinsic magnets because they rotate themselves. But exactly how do electrons move to create magnetic effects? An atom with a filled shell of electrons will move around equally, and the electrons' intrinsic magnet's force will cancel each other out. Therefore, will not be magnetic. While an atom with a half-filled shell of electrons don't move equally throughout the atom, and the electrons' intrinsic magnets go in the same direction, which creates a magnetic atom. But that's only atoms. We know what makes an atom magnetic, but what about whole objects? When atoms connect together to create an object, they either align equally to make a magnetic effect or unequally to cancel the magnetic effect. The atoms will align based on whatever requires less energy. There is also the case of domains, which are chunks of atoms. Some ferromagnetic materials may have some chunks of atoms pointing one way, while others are pointing different ways. It will not be magnetic if the domain sizes are similar, since they cannot force others to align. But if you apply a strong enough magnetic force from outside, you can force the domains to align together. So in order to be a magnet, the domains of the object must align, and each domain's atoms need to be aligned, and the atoms need to have an approximately half-filled shell, which have unpaired electrons going in random directions. There's a quite rare criteria. So when magnets are made, they're typically made using iron, cobalt, nickel, or gadolinium. Or you could just run an electric current through a metal, which creates an electromagnet. I'll stop this thing here.